5 kilogram block is set into motion upon an inclined plane with an initial speed of 8.00 meters per second. The block comes to rest after traveling 3 meters along the plane, which is inclined at an angle of 30 degrees to the horizontal. For this motion, determine A, the change in the block's kinetic energy, B, the change in the potential energy of the block Earth system, and C, the friction force exerted on the block, assumed to be constant, and D, what is the coefficient of kinetic friction?
Alright, so this is chapter 8, number 33. So at the top is the diagram, including all the givens, which are that there's a 5.00 kilogram block. The initial velocity is 8.00 meters per second. It is 3.00 meters along a plane, and the angle is 30.0 degrees to the horizontal. Part A, we are trying to find the change in the block's kinetic energy, or delta K. So to find delta K, we are going to use the equation delta K equals 1/2 m v final squared minus v initial squared. And you can simplify that to get negative 1/2 mvi squared. The equation negative 1/2 mvi squared, and you can plug in your givens. So you can plug that in to be negative 1/2 times 5.00 kilograms, 8 times 8.00 meters per second squared. And once you plug that in, you get negative 160 joules for part A. So for part B, you're trying to find the change in potential energy of the block Earth system, or delta U. For that, you can use the equation delta U equals mg times 3.00 meters times sine of 30 degrees, and again, all of these were included in the givens, and you can get an answer of 73.5 joules. Okay, and for part C, we're trying to find the friction force exerted on the block, which is a constant. So for part C, we know that the mechanical energy converted due to friction is 86.5 joules. Now you can take 86.5 joules and divide it by 3.00 meters to get an answer of 28.8 newtons. So for part D, we are trying to find the coefficient of kinetic friction. So for this part, we are actually going to use the equation F equals UK times N. Okay, so F and N can be substituted, so you get the equation UK times mg cosine theta equals 28.8 newtons, and now we will rearrange to solve for UK. So now we get the equation UK equals 28.8 newtons divided by 5.00 kilograms times 9.80 meters per second squared times cosine theta. And this was just plugged in with the givens, or what you had found in previous parts from the prior equation, and now you get the answer of 0.679.